Now that we have our geometry background, we can actually get into the trigonometry. Students always freak out. Trigonometry sounds so hard, but what does the name trigonometry mean? What is the prefix tri? Three. Trigonometry is the study of triangles, which doesn't sound near as scary. So in section 1.3 now, we have just one definition here, and it's a long one, but let's just read through it line by line and see if we can draw a picture. It says, let xy be any point besides the origin on the terminal side of an angle theta in standard position. Be careful, that's the Greek letter theta. We typically use that for angles, right? Theta. It's not a zero, okay? Please don't mistake it for a zero. Okay, so it says something about theta in standard position, okay? I'm just going to draw an angle in the first quadrant, and we could have drawn it anywhere. So I'm going to say theta looks like this. So there's my angle theta. I'm assuming it's just some positive acute angle. Okay, so there's an angle theta. Standard position means the initial side is here, terminal side can be anywhere. Let xy be any point besides the origin, so I can't choose the origin, on the terminal side of angle theta. Okay, so I'm just going to pick xy out here. Okay, so let xy be any point besides the origin on the terminal side of angle theta in standard position. That's what the first sentence says. There are a lot of words, but it's not a very complicated picture. It says the distance from the point to the origin. So the point I've chosen, the distance from that point to the origin, they're calling r. Okay, so r is the distance from the point to the origin. And they give you a formula here. Okay, so the way I'm always going to draw my triangles like this is always from the point you've chosen on the terminal side, draw your triangle with a vertical line, not horizontal. Draw your triangle with a vertical line and make a right triangle. Well, how far is it from here to here? Well, how do you plot that point xy? Again, here x and y are both positive, so I'd move over x and up y. So that length is x and that length is y, isn't it? Right? X, y. Well, Pythagorean theorem says we're in a right triangle. X squared plus y squared is r squared. And I'm going to take the square root of both sides. When you introduce a square root, you normally take plus or minus, but r is positive, right? I put in the notes, I added that in parentheses, so r is greater than 0. Why is that? R is the distance, okay? So, and this point cannot be the origin, so it's a further away, so there has to be some positive distance there. So if I take the square root of both sides, I get r is the square root of x squared plus y squared. Again, I took the positive square root because r is the distance. Okay, so there's the first two sentences. Okay, so there's our picture. Okay, so I'm not going to erase that. Okay, so if you have the point xy, you can plot the point, you know that value, and you get r from this formula. Okay, easy. Right? So the definitions of the 6 trig functions are sine theta. Okay, now I know that sounds, okay, I actually wrote in the notes, the SIN stands for sine, S-I-N-E. Okay, and then we have cosine, tangent, cosecant, secant, and cotangent. Okay, those are the actual names of the trig functions, but we usually don't write them all out. So we abbreviate sine with S. Don't read it as sin theta, it's sine theta. Okay, so that's the definition of sine. Oh, we haven't written it yet. The definition of sine is you take the y value over the r value. Now, I put some extra words out to the right in the notes. That's really in the next section, but I thought I might as well just explain it to you now so you can get used to it. Okay? If you look at the angle in the triangle here, this angle right here, which in this example is my theta, but it doesn't have to be. Okay? Always use the angle in the triangle here that's near the origin. Don't use this angle. Y is the side opposite theta, and r is the hypotenuse. So you can think of this as also the opposite side over the hypotenuse. Okay, when I first learned trig many years ago, I learned it this way, not with y's and r's. But if you learn it one way, you can always translate to the other. See, I know sine is opposite over hypotenuse. That's the way I have it memorized. So when I look at this, I say, oh, opposite and hypotenuse. Well, that's y over r. So you can, if you have this picture, you can translate between the two. Okay, let's look at cosine. The definition of cosine is x over r. But x x, okay, now how is x related to the angle theta? Again, the angle in the triangle here, x is the side adjacent to the angle, and again, the hypotenuse. Now you might argue, well, wait a minute, at this angle right here, x and r are both adjacent to it, but r is a hypotenuse, okay? So x is the leg that's adjacent to the angle theta, okay? And then tangent is opposite over adjacent. Again, that's the way I learned it, but in my picture, what's opposite over adjacent? Y over x. Okay, so those are the three basic ones. Again, I'm going to get ahead of myself, which we're not going to do in this section, but we will later. If you know these three, you can get the other three. The other three trig functions are reciprocals of those. Okay, so cosecant of theta, right? Cosecant is r over y. It's the reciprocal of sine. Okay, now be careful. Just because, don't go with the names. Sine and cosine you would think would be reciprocals, but they're not. It's sine and cosecant. Cosine and secant are reciprocals. So secant is r over x, which is hypotenuse over adjacent. And then cotangent is a reciprocal of tangent, that's x over y, which is adjacent over opposite. Again, you just need to learn these. And you need to be able to spit them out. You can't, memorize a song that's going to take you 10 minutes to sing to figure out all these. Just be able to spit them out. Just learn one of them right now while you're watching this video. Sine is y over r or opposite over hypotenuse. Either learn the x's and y's or the opposite hypotenuse way, but you may need to use either way. So just make sure you can translate from one to the other using this picture. Like I said, I know cosine is is adjacent over hypotenuse. Well, that's x over r. Right. I know cotan is adjacent over opposite. That's x over y. Right. So I learned them this way, but I can say them that way by thinking of this picture. That's all trig is. What are these trig functions? You're dividing one side of a triangle by another. Now we're going to have another picture where we don't have a triangle, but that's basically what we're doing here, is the trig functions are one side of a triangle divided by another. So it's not as scary as it might seem. Now, there's going to be four standard types of problems we do where they give you information and then ask you to find the trig function values. Okay, so they're going to say, here's some information, find the values. Here's some other information, find the values. So the first type, or these first two examples, it says the terminal side of angle theta goes through the point 3, 4. So the terminal side of my angle passes through this point. So that's my point xy in my picture. Find the values of all 6 trig functions. Okay, well, let's draw a picture. I mean, you'll see almost every problem I draw a picture. I mean, there's geometry involved, so it sort of makes sense. And I'm not going to worry about the scale here. It doesn't 1, 2, 3, 1, 2, 3, 4. You don't really have to worry about the scale. Where's the point 3, 4? It's in the first quadrant. Okay, so there's my initial side. There's my terminal side. And I don't know the rotation of the angle. I like to put something in. So let's just say that's my angle, theta. It could go around 100 times and then stop here. The terminal side would be in the same place. Okay, now what's the procedure, right? So that's the point 3, 4. What did I do when I drew that last picture? I made a triangle by drawing what type of line? From the point, you draw it with a vertical line. The reason why I say vertical line is so the adjacent opposite stuff makes sense. If you draw it the other way, you're going to use the wrong sides. Okay, so I like to label my sides. So that's a 3 and that's a 4. All right, over 3 up 4, that's a point 3, 4. Well, we need to find r to find the trig function values. The formula is r is x square root of x squared plus y squared. Sorry. So if we keep working this out, that's 9 plus 16, which is the square root of 25, which is 5. Again, I like to put everything in my picture so I have it. Now, I chose these numbers on purpose. In this book, the Pythagorean triple, as it's called, 3, 4, 5, so the 3 sides of right, shows up so many times, you should probably just memorize it. Because there's no point working this out every single time it shows up. Now, be careful. 5 is on the hypotenuse. I mean, if you have a right triangle, and you have a 3 here and a 5 here, that's not going to be a 4. The hypotenuse has to be the largest side, so be careful. Okay? It's 3, 4, 5, where 5 is on the hypotenuse, and 3 and 4 are the legs. Okay, I have my picture. Once you have your picture, it's plugging and chugging here. I was going to use the definition, but you have it in the notes, so let me just get rid of all this. Okay, now here's how you label your answers. Don't just write down, 3/4, a floating answer. No, no, no. Label your work. So you say sine of theta equals. If you write sin equals, that doesn't make any sense. You have to take sine of something. It's like if you wrote square root equals 3. And students always laugh when I write that because they know it's so absurd. You have to take the square root of something, right? Okay? Same thing here. You have to take the sine of something, okay? So this is how you label your answers. So sine of theta equals, well, what was the definition of sine? It was opposite over hypotenuse, or y over r. And then what was the definition of cosine? Cosine was x over r, or adjacent over hypotenuse. That's 3/5. And tangent was opposite over adjacent, or y over x. Well, how do you learn them? With x. And then I find sine, cosine, tangent, and just take reciprocals. The reciprocal of sine is cosecant, so that's 5/4. The reciprocal of cosine is secant, so that's 5/3. Reciprocal of tangent is cotangent, that's 3/4. So if you just know the definition of these three and then know what's a reciprocal of what, then you can do all 6. So the work here was just drawing the picture. Once you have the picture, this is plugging and chugging. There's nothing to do, but you have to know the definitions of your trig functions. Okay, the next one's the same sort of problem. It says the terminal side of angle beta, that's a Greek letter beta, goes through the point -512. Find the values of the 6 trig functions. Okay, now it's not a theta anymore, it's a beta for some reason. Okay, let's draw a picture. Now, where's -512? -512 is in the second quadrant. Again, I don't know the rotation. I like to put something in, though. And I'm not worried about the scale. That's not important. Again, I drew my triangle. There's the point, -512. And I drew it with the triangle with a vertical line. All right, let's label the sides. Now, when you do the trig function values, notice it doesn't say the length of the side. It just says x and y and r. So notice x here is -5. So when we use x, we're going to plug in -5. So I know the length of this is 5, but I'm still going to label with -5 because -5 is x. So that's what's going to go in the definition. And then the y, -512, is over here. All right, so we need to find r. R is the square root of. Now it's x squared plus y squared. But -5 squared and 5 squared are the same thing, right? Because -5 squared is 25, which is the same as 5 squared. So I'm just going to write 5 squared. The reason why is students will often write this, which is not the same thing as this. Order of operations say do exponents first, then the negative. That's -25. And they'll type that in the calculator and then get a wrong answer. So you might want to do what I just did here. When you're doing this R calculation, if either x or y is negative, when you square, just leave off the negative. So that's 25 and 144, which is 169, and the square root of 169 is 13. And again, I chose these numbers. This is an example I made up because the Pythagorean triple 5, 12, 13 shows up through this book over and over and over again. So that's another one you just probably want to memorize. Again, 13 has to be on the hypotenuse though. So 3, 4, 5, and 5, 12, 13. They'll show up over and over again in this book. Okay, so the hypotenuse is 13. Okay, pause the video and see if you can do the 6 trig functions for this example, and then I will do it and we'll see if we get the same thing. Okay, so let me quickly write down the answers. Now be careful, when I say opposite and adjacent, I'm referring to the angle in the triangle next to the origin. So that's the angle I'm talking about. Now this is angle beta here, right? This is not beta, beta's here. But we use this in the triangle to help us. So there's the opposite, there's the adjacent, there's the hypotenuse. Okay, so it looks like sine is 12/13, so cosecant is 13/12. Cosine is negative 5/13, secant is negative 13/5. Tangent is 12 over negative 5, so that's negative 12/5. And cotangent is minus 5/12. And again, I don't care where you put the negative. Remember, when you have a fraction, right, if you have negative a over b, that's negative a over b, which is a over negative b. I don't care which way you write it. If I think about it, I'll put it out front, but I may not. Like here, I just put the negative 5 up in the numerator. Okay, so I don't care. Okay, so that's that one. Okay, so that's one way, one type of problem they'll do it. They'll give you a point on the terminal side of the angle in standard position, and you find the sixth trig function. So that's one type. Now the next type is they give you a different piece of information, and it says the terminal side of angle theta, so the terminal side is on the line 3x plus y is 0, where x is less than or equal to 2. So they give you different information, and they only ask you to find two trig functions here, cosecant theta and secant theta. Okay, so they didn't ask for all six. Please make sure you read the instructions, right? If it says find these two, don't waste your time finding all six. I'll have students say, I didn't have time to finish your exam. It was just way too long. And then I look at their solutions, and on a problem where I asked for two, they gave me six, and they did this, six times. So they run out of time because they're doing all this extra work. Okay, so make sure you read the instructions and answer the question that was asked. Okay, so here the terminal side of angle theta is on this line, right? Notice if you take the 3x over, it's y equals minus 3x. That's a line, y is mx plus b. But why did they give you this extra condition? Because, and notice this passes through the origin. 0, 0 satisfies the equation. So ignore this for a second. If I have a line that passes through the origin, well, this one's in the second quadrant and the fourth quadrant. Notice this one's in the first and the third. So, the terminal side is in one quadrant, right? When you draw an angle, you don't have that and that for one single angle. So this condition here is to help you narrow down, right? So for example, let me look at this line I have darker here. So if we have this line right here, notice if x is less than or equal to 0, it's this piece, because here x is positive, right? X, and then y would be negative, so it's not that. So this condition is narrowing down which quadrant you're in. That's all it's there for. Well, a standard thing in math is reduce a new problem to one you've already done. If we could just find a point on this line that satisfies that, we have the point on the terminal side and we're back to what we just did. So what you could do, just pick your favorite x value that's strictly less than, don't pick 0, because if you pick 0, you get 0, 0, and you're at the origin. That doesn't help you. Well, I'm just going to pick something out of the blue. So let me let x be negative 1. I just picked something. Okay, well, if it's on this line, it must satisfy the equation. So let me put negative 1 in for x, and let's solve for y. And if you add 3 to both sides, you get y is 3. So the point we're interested in here is negative 1, 3. Okay, so I just picked negative 1 out of thin air. Now I made sure it was less than 0 to satisfy this. Okay, and I got y would have to be 3. So this is a point on this line that satisfies that condition. So this is a point on the terminal side of the angle. Now we're back to where we were before. Now where's the point negative 1, 3? That's in the second quadrant. So it's up here somewhere. There's my terminal side. And again, I don't know the rotation. I just put something in. I didn't make my picture very big. There. All right, so x is negative 1 and y is 3. Now, for cosecant and secant, there's r involved, so we have to find the r. So r is the square root of 1 squared plus 3 squared. Again, I did just put 1 instead of minus 1, because 1 squared and minus 1 quantity squared are the same thing. Looks like it gets squared to 10. Now, oftentimes in the instructions in my notes and in the book, which I didn't do it here, the instructions will say give the exact value, meaning don't punch in the calculator and round. So leave square root of 10 and square root of 10. That's exact. right? So don't put it in, put 3 point blah, blah, blah. No, that's not exactly more you grounded. Okay, so now we just have to fill in. So what's the definition of cosecant? Cosecant is hypotenuse over opposite. Again, when I say opposite, I'm referring to the opposite of the angle in the triangle there by the origin. So angle theta is here, but we use this for the opposite adjacent. So there's the opposite, there's the adjacent. So cosecant is r square root of 10 over opposite 3. And secant is r square root of 10 over the adjacent negative 1, which is minus root 10. Okay. So again, all the work was doing this, right? Using this information to find a point on the terminal side, drawing the picture just like we did in the previous 2 examples, and then plugging in your definitions. Okay, please don't make this harder than it is, but you have to know the steps. I'll have students, I don't even know what to do. And if I say, draw the picture, oh, okay. Find R, oh, okay. Now use the definitions, oh, okay. When I tell them what to do each step, they can do it, but they don't remember the steps. So you have to remember the steps. First do this, then do this, then do this. Okay. Now the next example says, since we enjoyed this problem so much, it says do it again with a different point, right? So they want us to do the same problem again, but with a different point. So instead of negative 1, 3, they want us to choose something else. So the steps are going to be exactly the same, won't they? Let me write what we used up here just so I will still have it. Okay. Okay, so we're going to do the problem again, but choose a different point. So I'll do that work down here. Okay, so, well, let's just pick a different value for x that's less than 0. How about x is negative 2? And why not? And now I need to figure out what y would be. So 3 times negative 2 plus y is 0, right? If a point's on this line, it must satisfy the equation. So if x is negative 2, I plugged it in. I get negative 6 plus y is 0. If you add 6 to both sides, you get y is 6. So my point here is negative 2, 6. Okay? So again, I'm going to be in the second quadrant again. We already knew that. And again, I'm assuming there's angle theta. Draw your triangle with a vertical line. The x value is negative 2, the y value is 6. Okay, so let's figure out the r. Well, r is the square root of 2 squared plus 6 squared. Right, square root of x squared plus y squared. And I get 2 squared is 4 and 36. So I get square root of 40. Okay, well, I have my triangle picture here. Let's do the definitions. I need cosecant of theta and secant of theta. Well, what's the definition of cosecant? It's r over y. It's a hypotenuse over opposite. So it's square root of 40 over 6. And secant is square root of 40 over negative 2. Okay, so that's out. Now, what was the point of the problem? Well, if you go back to the definition of the 6 trig function, the very first definition we did, the definition said let x, y be any point besides the origin on the terminal side of angle theta. Now these two angles are exactly the same. These terminal sides are exactly the same. But I chose that point, and there are 2 different points on the terminal side. In the definition it said pick any point besides the origin on the terminal side that you want. Well, if you pick this point and I pick this point, and then you compute the trig function values and I compute the trig function values, if we don't get the same values, the definition is stupid. It doesn't make any sense, right? We should be getting the same values or the definition's not well defined. So the question is, are these the same thing? They better be. Well, I sort of led you down the garden path here because I wanted to make these look different to make you think they're 2 different answers. But you can simplify square root of 40, right? Right, square root of 40, you can rewrite that as 40 is 4 times 10. So that's the square root of 4 times the square root of 10, which is 2 root 10. So I can replace square root of 40 with 2 root 10. And notice you can simplify, a 2 cancels with the 6. You get square root of 10 over 3. And here the 2's cancel, you get minus root 10. And notice we do get the same answer. Okay, so that was the point of these two problems, to show you. It doesn't matter what points you choose on the terminal side, you're going to get the same trig function values. Right? Now, why does that work? Because the numbers were different. Why do we wind up getting the same answer? Well, let me go back to this picture right here. Let me extend this one. All right. So let me extend this out a little bit and make a second triangle. So minus 1, 3 is here, minus 2, 6 is here. Okay. Now think about what we just did in doing, say, the cosecant, right? For the first problem there, right, what did we do? We took root 10 divided by 3. And then what did we do when we did it the second time? The length here was root 40, or 2 root 10, and this side was, 6? So think about what we did. Cosecant was that over that the first time, and then it was that over that the second time. Now, why should we get the same answer? Well, the two triangles here are similar triangles. Here's a right triangle and here's a right triangle. They both have that angle the same. They both share that angle. That angle's in that triangle and that angle's in that triangle, which forces these two angles to be the same. Or you could also argue, right, two parallel lines cut by a transversal. These are like corresponding angles. Is that right? Yeah. Okay. So the two triangles are similar, which means that divided by that is that divided by that, from the example we did in the last section. So that's why it works, because you're doing similar triangles. So the ratios are going to be the same. Okay. So the note here, the values of the trig functions do not depend upon the point chosen on the terminal side. Why is this true? Because when you pick different points, you create similar triangles, so the ratios are preserved. Okay, so that's why it works. Okay, now the other type we're going to do, everything we've done so far, we had a triangle picture involved. Okay, so the last type is not going to involve a triangle picture. So when we do these the trig function values, you're either going to have a triangle picture or you're not. So the triangle pictures are what we just did. So the next example says, find the values of all six trig functions for alpha, that's the Greek letter alpha, is 90 degrees. So this is the third type, right? What were the first two types? They gave us a point on the terminal side, find trig function values. The second type was the terminal side lies on a line with a restriction, find the trig function values. This is the third type. Here's an angle. Notice in the previous two examples, I had no idea what the actual angle was. Was it 20 degrees or 100 degrees? I have no idea. We didn't need that. And here they gave us the angle. Okay? So, initial side is here. 90 degrees, I know that is the actual correct rotation. So there's a picture of 90 degrees. Now, in that definition, at the beginning of the section, I drew a triangle picture to illustrate it, but it doesn't have to be a triangle picture. Okay? I've sketched the angle. What did the definition say? Pick a point on the terminal side of angle theta besides the origin. Okay, so here's my angle. Here's the terminal side. I want to pick a point on the terminal side besides the origin. Well, they didn't give me anything to go on, but can't you give me the coordinates of a point on the positive y-axis? I'm just going to pick something, 0, 5. Now, you can pick 0 anything, but not 0 and not a negative, right? 0, 0 is here and 0 negative is down here. So 0, any positive numbers. I just pick 5 out of the blue. You can pick anything. Okay? Now, in the procedure before, I said, now draw a triangle. But how did I tell you to do it? I said, make a triangle from the point you've chosen, make a triangle by drawing a vertical line. That's not going to give you a triangle, right? There's no triangle picture here. I will have students draw from here and try to make a triangle. The problem is that you don't choose a point over here. You only choose a point here, right? So there's no triangle picture here. It's the other type, okay? Well, there's no triangle here, but can't you tell me what x is? Well, we chose x is 0. Think about it. You also can't draw a triangle if x is 0, right? A side of a triangle with length 0 makes no sense. And then what's y? Y is 5. Right? So we have x and y. The only thing left to find is r. You can still use x, y's, and r's. Okay? Now, we need to find r. Now, think about what r is here. What was the definition of r? R was the distance from the point you chose to the origin. Can't you look at the picture and tell me that distance? Well, that's the point, 0, 5, it's 5. Right? Now, if you don't realize that, if you can still use that same formula, the square root of x squared plus y squared, even in this situation, even though it's not a triangle, you can still use it. You get 0 squared plus 5 squared. The positive square root of 25 is 5, which is what I said it was anyway. Right? But you can just say, oh, that distance is 5. Okay, so there's your r. So you have your x, y, and r. And it says find all 6, okay? So I want sine. Now, if you want to put alpha, sine of alpha, that's fine. If you want to write sine of 90, that's fine. I don't care which one because they're the same thing. Again, you have to label your answers. There's no place for laziness in mathematics. Okay, so I want to find the values of all 6 trig functions. Now you have to be careful here. In the definition, it was x's and y's and r's. Notice opposite adjacent hypotenuse doesn't make any sense here. So you can't use that definition. You have to use x, y's, and r's. There's no opposite side, there's no hypotenuse, okay? So like I said, when I first learned trig, I know adjacent, hypotenuse, and opposite. Here you have to use the x, y, and r definition. But again, I just think of the picture, this, say x, y, r, and theta. Okay? So I'll tell you my thinking as I go, okay? So what's sine of 90 degrees? Well, sine of 90, I always memorized was opposite over hypotenuse. But what is opposite over hypotenuse? Y over r. So it's just y over r, 5 over 5. You should simplify basic fractions like that. Okay, again, cosine, I learned cosine was adjacent over hypotenuse. But what's the adjacent over hypotenuse? X over r. So I'm translating from what I memorized to the x, y's, and r's, because you have to use x, y's, and r's in this problem. So x over r is 0 over 5, which is 0. Okay, and then tangents, opposite over adjacent, or y over x. And y over x, notice that's 5 over 0. 5 divided by 0 doesn't make any sense. You can never, ever, ever, ever divide by 0. And 0 over 0 is still dividing by 0. That's still undefined. So this is undefined or does not exist or whatever you want to write. Okay. I didn't even write 5 over 0 because that doesn't make any sense. Okay, now what about cosecant? We just run through those as well. Cosecant is hypotenuse over opposite, it's r over y. So 5 over 5, it's a reciprocal of that one. So it's still 5 over 5, which is 1. Right, now I'm going through this because taking reciprocals of undefined doesn't make any sense. So the reciprocal of that one's no problem. Now what is this going to be? It's actually going to be 5 over 0, isn't it? Because secant is r over x. So that's 5 over 0, which is undefined. And then cotangent. Cotangent is adjacent over opposite, or x over y, and x over y is 0 over 5, which is 0. Remember, you can have 0 in the numerator, you can't have 0 in the denominator. So notice when you're doing that, this is a quadrantal angle. Remember, when the terminal side of an angle stops on an axis, it's called a quadrantal angle. When you do quadrantal angles, you don't have a triangle picture. You have a picture like this. And then you have to use x, y's, and r's. Opposite, adjacent, hypotenuse doesn't make any sense. Okay, so you can't say, oh, sine of 90, sine is opposite over hypotenuse. There's no opposite, there's no hypotenuse, okay? So you have to use x, y's, and r's. And again, I translate. I know sine is opposite over hypotenuse, so it's y over r, so use y over r in this problem. Okay, so that's that one. Then it says do it again for 180 degrees. And what letter am I using there? Okay, that's the Greek letter gamma, so gamma is 180 degrees. So we want to do this same procedure with 180 degrees. Okay. So pause the video and see if you can draw the picture for 180 degrees and identify x, y, and r. So just do that and stop there. Okay. So draw the picture, identify x, y, and r. Okay, well, 180 degrees, it's halfway around, so there's 180 degrees. And then we pick a point on the terminal side of the angle. There's the initial side, there's the terminal side. So you can pick any point you want. Now, you and I probably are picking 2 different points, but that's okay. You don't have to change yours. How about -4, 0? I just picked something. So you should have picked negative something, 0. So my x is negative 4, my y is 0. Now what's my r going to be? Remember, r is the distance from your point to the origin. The distance is 4 in my example. So whatever number you put here, negative 6, negative 2.7, you should have the positive value of that there. Okay? Okay, so see if you can do the 6 trig function values with your values, okay? Don't switch to mine. Go ahead and use yours, and then I'll do mine and we'll compare. So pause the video and do that. Okay, so let me work these out with my values, and we'll see if your values and my values match. Okay, so sine is y over r, so I'm getting 0 over 4 is 0. So you got 0 over your r value, you should have still gotten 0. Cosine is x over r, so you should have gotten negative 1. Remember, tangent is y over x, so tangent should have been 0. And then cosecant, you're going to get 4 over 0, which is undefined. Secant is 4 over minus 4, which is minus 1. And cotangent is undefined. So once you simplified your answers like I did mine, you should have gotten sine is 0, cosine is negative 1, tan is 0. Cosecant and cotangent are undefined, and secant is negative 1. And you should have labeled your answers just like sine of 180 equals the number, cosine of 180 equals the value, or cotan of the 180 equals, undefined. That's how you should be labeling your work. Okay, so the next problem is using the calculator to get these values. We haven't done that yet. So the instructions say use the calculator to find these 3 values, and then do it again for these 3 values. So we're just doing sine, cosine, tangent. Okay? Okay, so let's see if we can get the same thing. So, well, I'll just write the first one again. So sine of 90 degrees. Okay. So the sine button, right, here's the 7 on my calculator. The sine button is 2 above it right here, so S-I-N. Okay? So it's just sine, and it automatically, right, I typed in a sine, it gave me a parentheses. I'm going to put in 90. You don't need the degree sign if you're in the degree mode. And so and if I hit enter, I get 1. So sine of 90 is 1. Now, if you type that in and you didn't get a 1, you're in the wrong mode. So the mode button on my calculator is right here. So notice if I hit mode, oops, I have to turn it on. Okay, see, that's the menu on my calculator. Notice it's highlighted right there. Notice it's highlighted degrees. So if yours is in radians right there, you need to scroll down to it, move over using their arrows, and hit enter to change it to degrees. So if you don't have a TI 83 or 84, usually there's some indicator on your screen. It may have a little DEG sitting there. That means you're in degree mode. It may say RAD, which is radians, or it may say grad. Gradients is another unit that sometimes you will see on a calculator. So if it's one of these, you need to figure out how to switch over to degrees. Because if you don't, if you type in sine of 90, and you're in radian mode, it'll treat that as 90 radians, not 90 degrees. Those aren't the same thing. Okay, so see if you can do the others now. I'm not going to write them down because we already know the answers. So cosine, that button's right next to the sine button. Cosine 90, I got 0. And now tan of 90, the answer is undefined. That's why I wanted you to do this, to see what that looks like. When I hit enter, my calculator says ERR, error, domain, it says domain, okay? So you need to read the message. If it says, sometimes you'll see on a TI-84, error, and it'll say syntax. That doesn't mean the answer is undefined. That means you left off a parentheses or something. Or you use the negative sign instead of the subtraction sign. Something like that. Syntax is bad notation. So make sure you read the message. Error syntax is something you can fix. Right? Domain, error domain is saying you're asking the calculator to compute something it can't compute. Okay, so that's how you interpret that as undefined. Okay, now these, we don't have undefined. Let's do those quickly. Sine of 180. is 0. Cosine of 180 is -1. Tan of 180 is 0. Okay, so we know how to do those on the calculator. Okay, now this last example is also a calculator problem, but it's really for notation. Sometimes we're going to want to square trig functions. Right, in algebra, if you wrote x squared, that means x times x. Okay, so if I wanted to do, sine of x times sine of x, right, you're squaring the sine. So you could write this as sine of x, whole thing square. Okay, but that's not the notation we use. Whenever you're squaring a trig function, we put the square after the sign, above the sign like that, sine squared, just so you don't have to write the parentheses, okay? So these two mean the same thing. But the calculator is not going to let you type it in this way. It's not going to like that notation. So when we write it, we're going to write it this way, but when you type it in the calculator, you have to type it in this way. And actually, when you on my calculator, when you type SI, when you hit the sign button, it gives you an extra parentheses right there. So you're going to have to close off the x and then close off the whole thing. Okay, so the example says find cosine squared of 33 degrees. Now again, you cannot type this in the way it's written. You have to type this in as cosine of 33 degrees, like square. And again, the calculator is going to force me to put parentheses around that 33. So let's punch that in. I'm going to include the square here, so I'm going to type all that in. Parentheses, cosine 33. You should be playing along at home. Squared. Again, you don't need the degree sign here if you're in degree mode. So I got, if I go to 4 places, 7034 if I round to the 4th place, 0.7034. So hopefully you got the same thing. If you didn't, check your mode. You may be in the wrong mode. You may be in radians or gradients. So change it to degree mode. Okay. And then the next one says, do tangent cubed of 33. Tan cubed of 33 degrees. Again, it's to the 3rd power now. So it's the same thing, but it's to the 3rd power. So again, you would type this in as tan of 33 degrees cubed. Again, you don't need the degree sign. When you write it, you need the degree sign, but you don't need it when you type it in. So tangent 33, parentheses for the angle, parentheses for the whole thing, cubed. And I got 0.273 now, if you round to 4 places. Okay, so this is just a notation thing. So when you see powers on a trig function, that's what it means. It's the whole thing squared. Okay. So if you write this, if you write cosine of 33 degrees squared, that means square the angle, then take the cosine. This is take the cosine, then square. But typically, people will write that in parentheses just so there's no confusion. Okay. So there's a difference. These are not the same thing. Okay, so that's section 1.3.